Hi everyone, hope you're doing well. This is a video to go over day 96, which is applications of sequences. So this is our last day. We made it to our last day of sequences, yay. And today's going to be a lot of word problems and a lot of things that you would have seen on the old regions and stuff like that. And they're going to be 13 questions, kind of just random questions. This is what I want you to post on Google Classroom for me, please. So by watching this Edpuzzle, you're not only doing your classwork, but I'm helping you with your homework at the same exact time. So again, all of these questions should be done when this video is done and then posted all on Google Classroom. And then all you have to work on tonight is that take-home quiz for me. So, all right, here we go. So before I do anything, I want to just have you write down two little things. You want to make sure that you're always finding the formula first before finding a specific term. And that's something that I've been telling you like almost every single day, so you should know that by now. And then the second thing I want to write, if it doesn't say which formula to use the explicit formula. Okay, so the explicit is actually going to be easier for you than any recursive because you don't have to worry about finding anything before. All right, here we go. Question number one. So question number one has to do with this diagram. So we have not done a diagram question yet. It says describe the pattern. So that's going to be our rule that we did from way in the beginning that you see in the sequence of the figures. So what I need you to know moving forward now, if you see beginning, and I have mentioned this one time already, beginning is now going to be a sub 0. Only where it says the number 1 is it a sub 1. And again, I think I talked about this in yesterday's lesson. And then a sub 2 would be a sub 2. So it doesn't tell us that we should be counting the dots. So they just assume that you know that what they want you to write here is the number of dots. So this is 1, this one has 5, and this one has 9. Okay, you could definitely see that these increase by 4, so this is going to be an arithmetic. Okay, so arithmetic, the common difference is 4, and the number of dots grow by 4, and that's why the difference is 4. Okay, so describe the pattern. So you have to tell me what it starts with. So start with 1. And because it's arithmetic, you have to use add, and add 4 repeatedly. Okay, so yeah, that's it. So assuming the sequence continues the same way, how many there in 3 dots? How many dots are there at 3 minutes? So right after this one, the next one, we're just going to keep following that pattern of adding 4. And then 9 dots plus 4 would give us 13. So 13 dots altogether. Okay, how many dots are there in T minutes? So this is asking you for your general, and you know general is always explicit, okay? So explicit for arithmetic is a sub n equals a sub 1 plus n minus 1 times d. So now here's the only tricky part about this is I need to solve for T minutes. So anywhere that I see an n, it has to be a t. Now, because I really can't change a formula, I on the side have to have a key, and that's going to allow me to change these letters like this. Okay, so a sub 1 I know from over here is 1, and the common difference is 4. So we have 1 plus, make sure that it is a t because it wants t minutes, minus 1 times 4. And then you can distribute and combine your like terms. And you should get 4t, sorry, this should be 5, I don't know why I said 1, 4t plus 1. And there you go. And that should make sense because here, that number 4, that's our common difference. And then this right over here, I always say is your a sub 0. Okay, your common difference or your slope, and a sub 0 the y-intercept. And that's correct because look, a sub 0 is 1 right there. And common difference is 4. So we did it right. Yay. Okay, how many dots are there in 100 minutes? So basically it wants you to figure out when t is 100. So we're going to use our formula. A sub t equals 4t plus 1. Everywhere we see a t, we're going to plug in a 100. Okay, so a sub 100 equals 400 plus 1. And a sub 100 equals 401. And that is that. So again, we just figured out the dots. That's what we counted. Beginning is a sub 0. And then this was tricky over here. We had to do that key because we had to switch up the letters. So All right, here we go. Question number 2. Decide if each of the following scenarios are arithmetic or geometric, and then you want to write the formula. All right, so this first one, this was the flu question. Student comes to school, so a student, okay, that's a sub 0, comes to school with the flu, and then we talked about infecting 3 others, and then it keeps going and going and going. So this is a repeat, so this is geometric, okay? So again, the first person, that's a sub 0, comes to school, they affect 3 people, okay? So your a sub 1 is going to be 3. So after the first hour, right? After the first hour, 3 people, new people got infected. Okay, it's all about new people. And then after that, 1, 2, 3, 1, 2, 3, 1, 2, 3. So that's now 9. So a sub 2 is 9. You could see that the common ratio is 3 because 1 times 3 is 3 and 3 times 3 is 9. So formula, a sub 1 times r to the n minus 1. A sub 1 is 3. Your ratio is 3. Again, you know the Regents love to do this. They love to do it when you have those same exact bases. So it's going to be 3 to the first plus 3 to the n minus 1, which comes out to 3n, which is the same exact thing we did on our geometric day. Okay, letter B, excuse me, round 1 of the tennis tournament starts with 128 players. So see how it says 1? 1, you can assume that means a sub 1, okay? After each round, half of the players have lost or eliminated. Blah, blah. Round 2, they're 64, then 32. All right, so this goes from 128 to 64 to 32, and you can see they keeps getting halved. So anything to do with having something, you know about our exponential functions that we did in our functions 2 units. So you know that this has to do with geometric because geometric produces exponential functions. So a sub 1, right? 1 is 1/28, and halves, that is our ratio. So ratio is 1/2. So we have a sub 1 times r to the n minus 1, and we have 128 times 1/2 to the n minus 1. And no simplifying like we did on the one before because they're not the same bases. Okay, Paul has $680 in his savings account. Okay, so because this does not say, you know, in the first month or after the first week, or it doesn't say anything at all like that, you have to assume that this means the beginning. Okay, so he begins or starts with 680. Anything to do with starts is a sub 0. So again, today you really have to know if it doesn't say 1, you assume it's what you start with, which is a sub 0. Okay. So just try to keep that in mind as we're doing this. Okay, after 1 month, see there's that 1. After 1 month, he's got 758. The next month, 836, and then 914. Okay, so 680, 758, 836, 914. All right, so as you can see, these are pretty close together. So it's going to be arithmetic. So arithmetic. And your a sub 1, so look where it says 1, is going to be 758. And then my common difference, let's see, 758 minus 680 should give us 78. Okay, so the formula, we're going to do the explicit for arithmetic. So a sub 1 is 758. And then our common difference is 78. So 758 plus 78n minus 78, combine our like terms, 78n plus 680. Now this should make sense. This number right here is your slope or your common difference. That's what we have. This number right here was a sub 0, or your y-intercept is what we started with. Is that what we said we started with? Yes. So see, it all works. All right, so those are some random questions. Keep it moving. Oh, we still got one more in the section. Sorry, D. Okay, so the table shows the number of country club members. All right, so this 0 means a sub 0, 1 means a sub 1, so on and so forth. So these numbers differ by 100. So this is going to be arithmetic. Your a sub 1, look for where it says 1, is 200. And then your common difference is 100. So a sub n equals a sub 1 plus n minus 1 times d. 200 plus n minus 1 times 100. That's 200 plus 100n minus 100, and that's 100n minus, plus 100. A sub n equals 100 n plus 100. All right, number 3, you won the lottery. Woohoo! You received 1 cent on day 1, 3 cents, and then 9 cents and 4. Okay, and again, see how it says day 1? Day 1, I now know that means A sub 1, so keep that in mind. Okay, write an equation. But equation, they also mean formula. Those words are kind of interchangeable. That represents the amount of money that have 1 in terms. Okay, so what kind is this? Arithmetic or geometric? So 1, 3, 9. So this is going to be geometric. And your ratio is going to be 3 because 0.01 times 3 is 0.03 times another 3 is that 0.09 times another 3 is that 0.27. So that's what it is. Okay, so we need A sub 1 is 1 cent and the ratio is 3. So let's do our explicit. A sub 1 is 0.01 and 3 is your ratio and no work needed. Would you rather be given $100,000 today or accept the lottery for the money after those 16 days? So 16 days is going to be your n equals 16. So first of all, I need to figure out what that is because I don't even know what that is at that point. So I'm going to use this formula right here and I'm going to have n for 16. So A sub n equals 0.01 times 3 to the n minus 1. So that's 0.01 times 3 to the 16 minus 1. So 0.01 times 3 to the 15th. What's 3 to the 15th? 3 caret 15 is 143,48907. Okay, so 14 million. And then we times that by 0.01, and we get 143,489.07. So $143,489. So would you rather wait 16 days and get $143,000 or take the $100,000? Well, I'm definitely going to go for the lottery after lottery money after 16 days. And that's basically because that amount is going to be bigger than $100,000. So I definitely want more. Okay. And the reason, again, you're getting more for after the 16 days because you keep adding on. You keep adding on from the day before. So, all right, number 4. So this is going to be really important. Remember this question. This is going to be on your take-home quiz. So keep this in mind. All right, Joey has a balance of $100 on his school cafeteria. Now, notice it does not say, again, it does not say after the first month or on the first week, or it doesn't say anything at all about that. So you assume this means the beginning or the start, which is A sub 0. Okay, that is not A sub 1, that is A sub 0. He buys a hot lunch each day of school. After day 1, he has this much. Okay, so now we have our A sub 1. A sub 1 is 97.25. So be really careful. When a lot of kids do this, they want to use 100 as A sub 1, and that is not correct. Okay, after the second day, he buys 94.50, and so on and so forth. Okay, so this is going to be 100. All right, so it's going to be arithmetic, and the difference is going to be negative 2.75. Now, it makes sense that it's negative because the numbers keep decreasing. Okay, so again, write an equation. Equation, formula, same exact thing. And as I said, this is arithmetic because each one of these just keeps decreasing by 2.75. So that means that's how much his school lunch costs. So I wonder how much our school lunch costs. I don't know. All right, so A sub 1 is 97.25. And our common difference is negative 2.75 because we keep losing money. So here is our explicit. A sub 1 plus n minus 1 times d. A sub 1 is 97.25. It is not 100. 100 is A sub 0. That's what he started with. Plus n minus 1 times, now be careful, you need this parentheses, so it looks like multiplication, and it doesn't look like subtraction, so be careful. So A sub n equals 97.25 minus 275n plus 275, and then we get negative 2.75n, and if we add those two numbers together, we get 100. Okay, now that's your equation. Again, that should make sense, okay, because this number right here that you get, which is your slope, is also your common difference, so that matches. And this number right here that we always get is your y-intercept, or A sub 0. And if we go back, A sub 0 is what he started with, so all of that makes sense. Okay, how many school days can he continue to buy the same lunch while only using the money that's on his account? Okay, 2 ways to do this. Easy way. You take the $100 and you divide it by how much the school lunches cost, and that's $275. I don't know why I wrote $276. $275. So 100 minus 275, or divided by 275, is try that again. 100 divided by 2.75 should be 36.36 repeating. 36.36 repeating. Now, we've been doing this a lot this year. So, can you buy 36.36 repeating of a lunch? Can you buy 0.36 of a lunch? No way. Okay, so now you have to decide, is it 36 lunches or is it 37 lunches? Do you have enough money on this account to buy 37 lunches? Well, let's check. 37 times 2.75. Nope, that's not good. But 275 times 36, I do have enough money. Okay, so at most 36, how many school days? At most 36 days he could buy lunch for, okay? The other way, the fancy Regents way, is to use the formula that you created, and you're actually going to put 0 in for a sub n, okay? And that means you have like $0 left. I've also seen this done with inequalities as well, because it makes a little more sense. And then we basically just solve it, and you're going to wind up getting the same exact answers you did before, which is that 36.36 repeating. And again, it's still at most 36 days. And we proved it because for the $99. All right, number 5. So if f of 1, oh, you know the Regents loves the function notation. F of 1 is 4, and f of n equals f of n minus 1 plus 10n, then find f of 3. Okay, so just remember that f of n is the same as a sub n, and then f of n minus 1 is the same as a sub n minus 1. So this is going to be your recursive. Okay, so because of this, this is going to be recursive formula. They just changed the a sub n to f of n and changed the a sub n minus 1 to f of n minus 1. But you got this, don't worry. Okay, so in order to figure out f3, I need f2. Anywhere here do I see f2? No, so keep that in mind. So f of n equals f of n minus 1 plus 10n. So all I did was copy this. So I need to figure out f of 2 first. So for this first one, n is going to be 2. So f of 2 equals f of 2 minus 1. Okay, and again, when you're doing recursive, this means recursive. I've got to get the one before this first. That's why I'm doing f of 2. So f of 2 equals f of 1. Okay, and this makes sense. If I'm doing f of 2, I'm going to have to use my one before it. So f of 1 is 4 plus 10 times 2. F of 2 is 4 plus 20, and I believe f of 2 is 24. So now that I have this, now I can figure out f of 3. So now we're just going to have n equaling 3 instead of n equaling 2. So f of n equals f of n minus 1 plus 10n. Now plug in your 3. Okay, so if you went to go plug in 3 right away, you would have noticed that this would have come out to be f of 2. Okay, and now anywhere on your paper, do you see f of 2 in the question? No, so that's why you actually had to start with the f of 2. So f of 2 is 24, and that's going to be f of 3 equals 24 plus 30, and 24 plus 30 is 54, and that is our answer. All right, page 2 done. Okay, number 6, another weird question. All right, so given the recursive formula, f of n equals f of n. Remember, this is the same exact thing. I just went over it. This is a sub n, and this is a sub n minus 1 plus 3. So this is the recursive that you are basically used to seeing. And this right here, by the way, because it's a common difference, it's plus, that's going to make this arithmetic. So keep that in mind. So we have our formula, and we have this, and we know that this is recursive. Oh, yeah, this tells right there. All right, find the first 4 terms of the sequence. We already have the first one. So for the second one, we have f of n equals f of n minus 1 plus 3. And we have f of 2 equals f of 2 plus 1, which is f of 1 plus 3. F of 1 is negative 5. I need to switch pencils, sorry. And then f of 2 equals negative 2. Okay, so that's where n is 2. Now for n is 3, so f of n minus 1 plus 3, f of 3 equals f of 3 minus 1, which is f of 2. Okay, f of 2 is negative 2, and 3 minus 2 is 1. All right, first 4. So we got one more to go. So now we want n equals 4. So f of n equals f of n minus 1 plus 3. So we have f of 4 equals f of 4 minus 1 plus 3. F of 4 equals f of 3. Okay, what was f of 3? F of 3 is 1. So f of 4 equals 1 plus 3, and f of 4 equals 4. So we have negative 2, 1, and 4. Okay, so now we want to find the first 4 terms. Rewrite those 4 terms ordered pairs. Okay, and graph it. So we have not done this yet, so I'm glad we're doing this. So when I have you figure out f of 2, and then we get the answer is negative 2. Remember, the number inside here is your x. So actually, let's start with the beginning one. So remember, this is your x, and this is the y value. So we're going to have 1, negative 5. Then we'll have 2, negative 2. This is 3 and 1, and this is 4 and 4. So now we're going to graph it. 1, 2, 3, 4. 1, negative 5. 2, negative 2. 3, comma 1. 1, 2, 3, 4, 1, 2, 3, 4. And there we go. Remember from way from the beginning, do not connect the dots. Okay, and 1 box equals 1 unit. All right, now in the explicit formula, again, we know from the beginning, this is arithmetic because you have that plus d. So we have f of 1, and I need my common difference. So f of 1 is negative 5. My common difference was already in the equation. That was 3. And now let's get to work. So, oh, actually, I can't even use a sub n. Let's use the function one because that's what is given. And this is good practice because we haven't done this in a while. So, having issues with my pencils. F of 1 plus n minus 1 times d. So instead of a sub n, we're going to use f of n. Instead of a sub 1, we're going to use f of 1. And it's good to practice this because we do have the function notation given. So it's good to practice this. So f of n equals negative 5 plus n minus 1 times 3. And that is negative 5 plus 3n minus 3. And that is 3n minus 8. Is that right? Yes, that is right. Okay, because that makes sense, because 3 should be the difference. Good. And then I guess if I kept following this back, right, this is down 1, 2, 3 over 1, down 1, 2, 3 over 1. It would land up right here. 1, 2, 3, 4, 5, 6, 7, 8. Yep, that would have been your y-intercept, which is negative 8. So again, arithmetic is the easiest one to relate back to, you know, our other stuff that we've done. All right, find the value of the 30th term. Which formula is more efficient for this question, the recursive or the explicit? So I'm going to write that first. So explicit formula, because you can just plug into the formula and you don't have to find out any previous term. So you just get the formula, you write it down, you plug in, you're done. So that's why explicit's better. That's why in the beginning I said to do the explicit to begin with. All right, so write that down. Then we have f of 30 equals 3 times 30. Okay, 3 times 30 is 90, and 90 minus 8 is 82. Okay. Number 7. All right, so we have another dot question just like we did on the front. So describe the pattern you see. So let's go through. So beginning. Okay, so what did I say? A sub what was beginning? You should say 0. Good. And then you have a sub 1, a sub 2, a sub 3, and a sub 4. So a sub 0 is 3. A sub 1 is 6. A sub 2 is 12. A sub 3 is 24, and a sub 4, 16 times 3, is 48. Okay, lots of dots to count. So what is the pattern? 3, 6, 12, 24, 48. Hope you can see that the rule is that this is geometric. Okay, it's geometric, and the common ratio is 2. All right, so here we go. Start with, remember, always tell me what you start with. So start with 3 and multiply. So the one we did in the beginning, that's what I was just looking for. This one, the one that we did in the beginning was arithmetic. Now we're going to do geometric. And multiply by 2 repeatedly. Don't forget repeatedly, that means keeps going. So the sequence continues. Okay, so 5 would be doubling this. So 48 times 2 is 96. So that would give me 96 dots. Okay, recursive this time we want to do. And we are doing geometric. Remember, recursive with geometric. And again, oh, they make it so tricky. So tricky. So we know we have to have a key. Okay, because we know our formula has ends. And we don't want to change that right from the beginning. We have to change it basically the second time around. All right, so I need a sub 1 and r. What was a sub 1? So look for the 1. So that's going to be 6. And then my ratio is 2. So, oh, actually, I don't even need the a sub 1. Really, I just need the ratio. And then that's going to be it. And then so important. Make sure you write where a sub 1 is 6. So we do need a sub 1, okay? Recursive, you have to know where it starts from. All right, now to do explicit with t. So again, I want another key. And I also need a sub 1. And I also need this. But now it's just a different equation. A sub 1 times r to the n minus 1. A sub t equals 6 times 2 to the t minus 1. And yeah, that one doesn't need any extra work. It doesn't need anywhere, anything. So you have your recursive and you have your explicit. A sub t minus 1 times 2. A sub 1 is 6. A sub t. All right, so all that looks good. Okay, we're moving. Number 8. Okay, given the explicit formula, write the recursive. So given the explicit, write the recursive. What do we have? All right, so these are in arithmetic form. Okay, because it basically looks like y equals mx plus b. Okay, and you know that arithmetic is always linear. Okay, so remember, this is going to be the slope or the common difference, and this is going to be your a sub 0. So just keep that in mind. Okay, now for the recursive, only need the common difference or the ratio. So this number right here, again, that's going to be your common difference, and this number right here is a sub 0. Okay, so recursive. So a sub n equals a sub n minus 1 plus d. A sub n equals a sub n minus 1 plus our common difference of 3. And don't forget to tell me where a sub 1. Now, is a sub 1 this value? I've gone over this a million times now. Is this value a sub 1? No, look, I have it right there. So we kind of have to figure that out. So we're going to have our formula that I'm going to copy right from here. And I want to know what a sub 1 is. And that's going to be 3 minus 1 or 2. Now, you could have probably figured that yourself out without even looking at that. If you know the difference is 3, okay, and you know you're starting with negative 1, just add negative 1 to 3 and you get 2. So could have been a lot easier that way. All right, next one. So we know this is the common difference, and we know this is our a sub 0. So a sub n minus 1 plus d. And then we have a sub n minus 1 plus 4, where a sub 1 equals, all right, so let's do it the quicker way this time. So we know we have a starting value of 3, our common difference of 4. 3 plus 4 is 7. A sub 1 has to be 7. If you want to do it the long way, plug in 4 times, glad I said I was doing it the quick way. 4 plus 3, and a sub 1 equals 7. All right, number 9. A taxi ride costs $3 for the first mile. So like, look, it says first. If it says first, you are assuming that is a sub 1. And $1.25 each additional mile. So that means you're going to keep adding $1.25. You heard me say adding, so this is common difference because this is arithmetic. Okay, write an equation again. Equation, formula, those are basically interchangeable, representing the cost in terms of miles, and then how much would the 20th mile cost. Okay, so it's arithmetic. So a sub 1, look for the 1. We know it's 125, so let's use our arithmetic explicit. So a plus 1, a sub 1 plus n minus 1 times d. a sub n equals 3 plus n minus 1 times 1.25. Distribute 1.25n minus 1.25. And we get 1.25n. 3 minus $1.25 should be $1.75. Okay, so what that means, this is our slope, which is our difference. That's correct. And then this is what your a sub 0 would have been. Remember, this is a sub 1. This is a sub 0. Okay, 20 miles. So that's n is 20. So just copy that formula. So 1.25n plus 1.25, or copy your equation, whatever you'd like to say. So a sub 20 equals 1.25. Nope, try that again. 1.25 times 20. And then let's see, 1.25 times 20 is 25. So 25 plus $1.75 equals $26.75. So $26.75. All right, number 10. So this kind of also goes back to our day 1. Okay, consider the sequence below. We've represented the sequence with the letter A, then do the following. So this is a sub 1, a sub 2, a sub 3, 4, 5, 6, 7, 8. The last time used was the first day of the sequences. Okay, so a sub 5, 1, 2, 3, 4, 5 is just the 5th number in the list. That is 25. A sub 2 was 7, and we're going to add a sub 6 to it, which is 31. 31 plus 37, plus 7 is 38. Okay, now this is just function notation. It's no different than subscript. Okay, it looks different, but the meaning is the same. So a sub 4 is 19, and then this is 2 times a sub 6. So 2 times 31. Okay, so you can definitely do this. Don't worry about how it looks. You guys got this. So the square root of a sub 5, I'm assuming it's a perfect square, which it is. A sub 5, we just did that as 25. A sub 3, 1, 2, 3 is 13 over 2. What's 25 minus 13? 12 over 2, and that is 6. Find a recursive definition. So definition just means another word for formula. So don't let this mess you up. All right, so is this arithmetic or geometric? These numbers keep increasing by 6. So we are going to work with arithmetic. So we need a common difference. A sub 1 is 1, okay? A sub n equals a sub n minus 1. The only thing I didn't say is that, hopefully I said this before, when they give you a list of numbers, you do assume that this is the first number. You do assume that's a sub 1. So I don't think I said that, but there you go. Plus 6. And don't forget, recursive have to tell me where a sub 1 equals 1. Okay, very, very important when you guys go to hand that in your take home with that, okay? Make sure you always put the recursive. All right, last page. Here we go. I'm trying to go quick so this doesn't take forever. Erin is traveling abroad this summer and would like to have a bit of spending cash while she's overseas. She has $100 already saved. Okay, so notice it doesn't say in her first month, in her first whatever. So you assume that this means a sub 0, okay? Saving $4 a month. So since it will constantly be the same exact thing each month, you assume that that is difference, okay? And difference is arithmetic, just like it was over here with our taxi question. So this is going to be arithmetic, so let's keep that in mind. So fill out the table below for the amount of money she saves as functions of how many. Okay, so the first month, she had already saved, oh no, so I'm sorry, so a sub 0, so this was like this, so 0 would be 100. Then she saved another $40, so 140. So just keep adding on $40, and that's what you get. All right, definition, just like on the front, on the other page, that's just another fancy name for formula. Give a recursive. Okay, so we're doing recursive for arithmetic for the sequence a sub m. They like to switch up the letters on us all the time, huh? Okay, don't forget to give initial value. Oh, that's nice of them telling us. Initial value is a sub 1. All right, so we need a sub 1. We know this is arithmetic, so we have a difference. 1, right? Here's a sub 1 is 140. The difference we were already told is 40. And now we have the pieces to our puzzle, so now we can get to work. So a sub n minus 1 plus 40. Don't forget to say where a sub 1 equals whatever it equals. Okay, graph the sequence from 1 to 5. Now this one's going to be a little tricky. This one you actually have to connect the dots, and because it wants all the numbers between those. So this one you really don't have a choice. All right, so for this, I'm just going to tell you what to count by. So count by ones here. 6, 7, 8. And then this side, count by, oh, it's already done. That one's already done for us. So this is 25, 50, 75, 125. You don't have to write this in, actually. I guess I started it, so I'm just going to keep going with it. Okay, and then we'll write Erin's savings, because we should always have a title. And then this should be number of months, and this should be money over here. Full amount of money she saves, function of how many months she has been saving. Yeah, so this is money saved, and then this is number of months. Okay, so we're not going to plot that one, even though I wrote it. So 1 goes with 140, and then 2 goes with 180, 3 goes with 220, 4 goes with 260, and 5 goes with 300, and you connect them. Get my ruler. Because it says it wants the numbers in between. It wants everything in between. So we're going to connect those dots. Okay, so that's a little bit of a weird question, but all right, moving on. 2 more. So if f of 1 equals 3 and f of x plus 1 equals f of x plus 8x plus 10, then find f of 3. And this gets a double star. This is, in my opinion, the toughest recursive they can give you. And we did one of these. I did one of these with you on the other page, on the other packet, excuse me, on a previous day. So f of x is the same as a sub n minus 1, and then f of x plus 1 is the same as a sub n, okay? So whenever you do recursive, and I didn't say this on the previous one, whenever you do recursive, it always means whatever is to the right of the equal sign is 1 less. So this is, n, and this is 1 less than that n. That's how you know it's recursive. Here, this is x plus 1. This is 1 less than x plus 1, right? So if I did x plus 1, I took 1 less than it. Those would cross out, leave me with simply just an x. That's how you always know it's recursive, okay? All right, here we go. Toughest one. But you got this. So f of x plus 1 equals f of x plus 8x plus 10. And also, how did I know this is the toughest one? By just looking at it. Here, you have the x minus 1 to the right of the equal sign, and this is plain old, x or n, whatever. This is where you have that x plus 1 or x minus, or whatever they give you to the left. That's when it's the toughest, okay? So to get f of 3, I have to figure out f of 2 first. Okay, in order for this to be f of 2, can I just make the x a 2? Well, 2 plus 1, is that 2? No. So the x has to be 1. And again, we did one of these tough ones on a previous page. Okay, so x is going to be 1, so 1 plus 1 is 2. So f of 1 is 3 plus 8 times 1 plus 10. So f of 2 equals 3 plus 8 plus 10. And again, it's recursive because to figure out the second one, you want to use the first one, use the one before it. So f of 2 is 21. Okay, so now the next one, we're going to have x equals 2 equals f of x plus 8x plus 10. So again, it's going to be 2 because I want to figure out f of 3. But what am I going to add to 1 to get it to be a 3? And that's why it has to be the 2. So everywhere you see an x, you're going to put a 2. So f of 2 is this answer right here, 21 plus 8 times 2 plus 10. So that's 21 plus 16 plus 10. What do we got? 26, 46, 47. So 47 is f of 3. So that is the toughest kind you can get, and the Regents, loves to be difficult. All right, 13, last but not least, we are almost done. Fred decides to cover the kitchen floor with tiles of different colors. He starts with a row of 4 tiles of the same color. He surrounds these 4 tiles with border tiles of a different color. Border 1. All right, so we're talking about the borders here, okay? Oh, and look, it says 1, so automatically that's, by the way, a sub 1. The design continues as shown. So we want to figure out the type and we want to figure out a general formula. Okay, so this would be a sub 2, and this would be a sub 3. Now it says border, so that means you, you know, that's how you know you count, dark tiles, because you're counting the border. 8, so this is 10. 1, 2, 3, 4. 8, 9, 10, 11. This is 14. And then 18. Okay, so the numbers keep going up by 4. So this is definitely going to be arithmetic. A sub 1, remember it says 1. If it says 1, you assume it's A sub 1. If it says nothing, you assume it's the beginning A sub 0. And your difference is 4, and it's arithmetic. So let's just, A sub n equals A sub, arithmetic. A sub n equals A sub 1 plus n minus 1 times d. And A sub 1 is 10 plus n minus 1 times your common difference. Your common difference was 4 because the numbers kept going up by 4. And this is 10 plus 4n minus 4, and that's 4n plus 6. Let's see, does that make sense? 4, yep, because it keeps going up by 4. This is A sub 1. If I wanted to figure out A sub 0, I'd do the opposite, so minus 4 times 4. Yes, so that is correct, and that is your formula. Okay, so I know it was a long video, but everything is done for you. Your classwork is the same thing as your homework, so everything I just did with you, these 13 questions, these 5 pages, please post on Google Classroom, so you get credit for today's lesson. If you have any questions, please reach out to me. And now your homework for tonight is going to be the take-home quiz on sequences. So make sure you get that done and hand that in. All right, have a great day. Take care.